Hello everyone, welcome back to Nated Engineering. We are still on Engineering Science N3, and today we will be doing a question from a question paper that was written on the 8th of April 2015 on forces topic. It's question number 3 and it reads as follows. We're going to start from 3.1. They say explain the term scalar quantity. A scalar quantity is a quantity that only possesses magnitude, not direction. So the definition is a quantity that only possesses magnitude. An example, it's a mass. Then we go to the next one. It's 3.2. They say complete the following sentence by filling in the missing words. Write only the words next to question numbers. To question number 3 in bracket 3.2.1 and 3.2.2 in the answer book. A direct force is a force which acts. The first one will be directly, and the second one will be perpendicularly onto an object. So we move on. They say name two types of direct forces. The first one will be a pulling force and the second one will be a pushing force. So we are going to 3.4. They say calculate the magnitude of the forces in the ropes P and T as shown in figure 2 below if the system is in a state of equilibrium. So this is the diagram that they gave to us. We are to calculate what? The magnitude of P and T. So we're going to start with the horizontal forces. They said the forces are in a state of equilibrium. We know then that the sum of the horizontal forces or components equals to 0, since the ones going to the left are equals to the ones going to the right. Therefore, we are going to start with 800 is going to the right is equals to the component of P. The horizontal component of P will be P cos 50 is going to the left hand side. We have this as the only unknown. We make it the subject of the formula, which will be 800 divided by cos 50. And this will give us the value of P as 1244, the 0.579. It's 579 newtons. We then move on. We are going to then calculate for the vertical component. We say the sum of the vertical component equals 0. The force that this force is going up according to the diagram that we are given. So our T will be going up. It's equals to the component of P. The component of P that is going down will be P sine, which is the vertical component, 50. So our T will be equals to 1244.579 times sine 50 is equals to 953 is equals to 403 newtons. And those are the values of P and T. We move on to the next question. They say determine the magnitude and nature of the forces in the members AB and DC of the roof truss in figure 3 below. We are given this diagram in figure 3 and we're asked to calculate for something I did not write here. This is C, this is B. We are asked to calculate for AD, which is this member, and CD, which is this member. We need to calculate for their magnitude and the nature. But we can see that we are not given the reactions A and D. So that is what we first need to calculate for. So we're going to take it as a beam, as we know how to calculate for the reactions. Where this will be our A, this will be our D. There will be a force acting here. Force of 10 kilonewtons. And there will be a force acting here. Force of 20 kilonewtons. And then we really need to calculate for the reaction of D, even if we do not get the reaction of A. But we do not have the distance between these two. So I'm going to say, divide this into 2. Let's say this is X and this is X. I'm saying this is X and this is X because I know that they are equal in length. How do we know that they are equal? These two forces are the same. These two angles rather are the same. Therefore, we can see that C is acting in the middle of this triangle. So we're going to say take moments about A. Moments about A. That will give us D. From A, the value of D will be 2x. Which is the force that is going up, times D. It's equals to the force that is going down, 20 times x. I'm not going to include this force of 10 because it will be 10, it's going down. We're going to have plus 10 times 0. We know any number times 0 is 0, so there is no point in us including it here. The same way y, whenever we're taking moments about A, we do not include A because yes, A does exist as a force, but the distance between A and A, since we are taking moments about A, is 0. That is why we do not include A. So we are not going to include this force the same way we do not include A, because the distance between the force and the point that we are taking moments about is 0. So I'm going to remove this. Now we are going to divide both sides by the x. Since we have the x in both sides, we're going to divide both sides by x. We can't divide both sides by x because we're only having multiplication signs. There's no addition sign here. So this will cancel out this will cancel out this. We are now left with 2d. is equals to 20, and our D is equals to 20 divided by 2, which is 10. D is 10 meters. No, not 10 meters. 10 kilonewton. D is a force. I'm sorry about that. So we now have the value of D. I'm only going to calculate for the value of D because we're only interested in we're only interested in this portion. So now we have the value of D as 10 kilonewtons. The reason why I'm going to calculate for D only is because it's not like they did specify to say calculate for the reactions first and then calculate for the magnitude of the members and their nature. So you can calculate for the other one, but it really isn't necessary, and I don't think there are marks for that. So I'm going to save my time and say we are only interested in this portion. This is 30. This will be D, and we're going to have C here, and we're going to have A here. No, it's not like the A is here and the C is here. Let's place it in that manner. We are now going to say the sum of the forces going up is equals to the sum of the forces going down. The force that is going up is D, and we know D is 10 kilonewtons. So we're going to give this direction towards this point. The component of D is here, so it will be CT. The component of CT, let's just say it's 10 kilonewtons. The component of CT, which is the vertical component, will be going down, and it will be CT sine 30. Remember, this direction we choose, and it is confirmed when we get the final answer. When we get the final answer is positive, it means the direction is correct. So here we are going to say the value of CT is equals to 10 divided by sine 30. And our CT, according to my calculator, is equals to 20 kilonewtons. It's positive, therefore we keep the sign. It will be like that. Mirror it, making it a strap. And then from there we are going to look at the sum of the forces to the right hand side is equals to the sum of the forces to the left hand side. The force that it's going to the right hand side will be the component of C, will be CT, cos 30. And the force that is going to that direction, so we're going to give AD this direction, the direction to the left hand side, and it will be 18. Therefore our 18 will be CT, which is 20 cos 80. And that will give us a value of 17.321 kilonewtons. It's positive, therefore we're keeping the form, the sign. It will be, we're going to mirror it, and that will give us a tie. We have calculated for the magnitude and the nature of AD and DC, meaning we have completed this equation, and that is it. That is what I had for this video. I will see you on the next lesson.